Alright, this video is meant to help you understand how to use augmented matrices to solve systems of equations. So one thing we can do with systems of equations is rewrite them as a set of matrices. And again, this basically comes from separating the variables from the coefficients and making a system of equations into basically a matrix equation. And if we take those variables and those coefficients, we separate them out, this is a matrix equation right here. So this matrix equation basically just says, again, remember we multiply rows by columns, and if we do so, if we take that second row by this first column, notice we'll get a 2x minus a y plus a 3z, right? Remember we add those parts together, which essentially is what we have on the left side of our equation down here in equation number 2. And because that second row by first column would be the second row first column answer, again, that essentially sets it equal to 9. By separating those apart, it gives us a way to solve that system. And there's a few different ways to do that. One of which, again, is taking advantage of what are called augmented matrices. So an augmented matrix is basically taking, again, that system of coefficients, that matrix of coefficients there that we have up top. And what we're going to do is grab the coefficients over here at the right, and we're going to attach them. We're just going to put them into the same matrix, 13, 9, and 38, as a fourth column. Instead of being a square matrix, a 3 by 3, this is now a 3 by 4 matrix. Sometimes people will even take a dashed line and kind of put it where the equal signs used to be. I'm fine with that, but just make sure you don't get those confused with your numbers. So basically, again, we've made one large matrix out of this. Again, we can kind of go backwards as well. You can interpret an augmented matrix. So you'll notice our dashed line here represents the equal signs. So this would have been a 5x plus 6y equals negative 10 system, right, or equation. Same thing, 4x minus 1y equals 3 is our system. So again, you can make augmented matrices or change them back into equations. They work both directions. Now the advantage of that is, that means that we can use row echelon form, or what we'll eventually call reduced row echelon form, to help us solve these systems. Again, we learned row echelon form when we worked with systems of equations before. So again, we had the ones down the diagonal, and remember we always wanted zeros below them, right in that lower left corner, or the lower triangular corner there. We want those zeros. Again, that's Gaussian elimination. Well, when Gauss got together with Wilhelm Jordan over here, they worked together and they actually took it another step farther. They called it reduced row echelon form. If we take those ones down the diagonal, again, get those zeros below them, but we also get zeros above them. Right? There should be no other numbers really here other than ones on the diagonal and zeros all around them. That's reduced row echelon form. And you'll notice that last column is still other numbers. Right? The rules to row echelon form and reduced row echelon form basically say any row of zeros has to occur at the bottom. So you'll notice in this matrix here, that's going to be a reduced row echelon form matrix, because we've got a row of zeros at the bottom, and you'll notice the ones at the far left, any non-zero row, right, has a leading 1. So again, that 1 is the first number from as far left as you can go other than the zeros. And for two successive non-zero rows, the leading 1 in the higher row is farther left than the lower row. So notice again, this one is just a little bit farther left than this one, and there is no 1 at the bottom. Which technically means, again, we've got our 1s on the step ladder. Notice we've got not zeros above it. That makes this one a row echelon form. We've got 1s on the step ladder with the zeros all the way down. Again, with zeros above them as well, that would be reduced row echelon. This would drag down here for me. Reduced row echelon form up there for you. Notice the zero's not in the middle here, so that's not row echelon or reduced row echelon. That's just a matrix. And same thing down here. You'll notice the 2 there, which means the farthest left number is not a 1. That's neither 1 as well. Which one do you think this bottom one is? Take a good look at it. We've got our 1s as far left as we can go. We've got zeros below those 1s. But notice the numbers above them, which means this, at best, is a row echelon form matrix. Well, if we can take advantage of that. What that means is instead of leaving a lot of extra numbers in our matrix, by using Gauss-Jordan elimination, we're actually solving all the way down to all of the variables. So we're going to use the same rules that we've used previously with matrices. So first things first, we need to change this system into a system of augmented matrices. So we're going to get rid of all the variables, and again, make it into one large matrix. Then we want to start with a 1 in the upper left. Our goal is going to be get that 1, get zeros below it. Then we'll work our way down the step ladder. We'll work to get a 0 or a 1 in this middle, the second row, second column, with 0 below that. A 1 in this slot here, third row, third column. And since there's nothing below that, we're not too worried. And then once we have those 1s in the lower zeros, then we'll go back and get these upper zeros. So step 1, I'm going to take first row and I'm going to cut it in half. I'm going to get that 1. Second step, well, notice I already had a 0 here, so what I did is I went ahead and multiplied by a half. I may as well get that 1 in place, a little bit of a step ahead. But notice I'm not grabbing any rows right here in my notation that weren't in the previous matrix. I'm not going to jump back 2 matrices. I'm not going to look forward a matrix. All of the stuff that I do has to come from the matrix right before it. So again, row 1 looks good. We got our 1. Then we want to get rid of this 7. So I went ahead and took 7 times row 1. And if I take row C, minus 7 of row D here, 7 minus 7 will get me that 0. And again, everything else just falls into place. Negative 5 minus 7 times negative 0.5. So again, plus 3.5. It's going to be a negative 1.5 here. Don't worry about the fact that we get decimals. They'll work their way out. And again, keep on going. So again, 0 minus 7 times 1.5 is negative 10.5. 6 minus 7 times 12 is going to be my negative 78. Again, you kind of just have to keep track of your numbers, do your best, take advantage of your calculator. Remember, you can always type these into your calculator as you go and just keep track of those numbers quickly and easily. Now that we have our 1 with our zeros below, I've got my 1 right here in the middle, second row, second column. I want a 0 below that. So again, I'm going to take advantage of that 1, changing it into a 1.5, and I'm going to add that on to row F. So again, 1.5 times 1 plus F. 1.5 times negative 0.5 plus F. 7 times 1.5 plus that negative 78, right? Plus row F. And that gets me this row down here at the bottom. Well, I've got 1 with 0 below it, 1 with 0 below it. I want this to be a 1, third row, third column. So let's just go ahead and divide that by negative 11.25, right? I can multiply a row by any number I want, including dividing it by any number that I want. Now that I've got my REF form, right, augmented matrix, what I want to do now is turn my zeros above those 1s, right? So that all of those numbers above those 1s will be zeros, and I'll have a much easier interpretation at the end. So again, first thing I'm going to do is grab this 1 down here and take advantage of the fact that if I add row 3, or any multiple of row 3, meaning I'm going to multiply those zeros and they'll stay zeros, when I add that multiple onto the row above it, I'm not changing anything above those zeros. I keep my 1s exactly how I wanted them. So again, half of the third row plus the second row is going to help me turn that second row, third column, and that 0 right here. Again, 1.5 or negative 1.5 times this one added onto the first row is going to get my 0 above there. If you follow the notation, feel free to pause the video and follow the notation yourself. And believe me, it'll work. Last thing to do is turn this negative half into a 0. Well, now again, if I'm going to add something to it and change it, I need to take advantage of that 1 that was right below it. But again, this 0 won't change my first column. My third 0 here, that's why I went and got that last time. That's not going to change my first column or my first row, which means the only thing that'll change if I multiply row 2 or row I by a half and add it to row 1 or row J, right? And notice I got a little bit of a typo here. I got to fix that up. But again, I'll end up with that nice, basically identity matrix, right? I've got 1s down the diagonal and I've got zeros above and below. that left side of this thing, the first 3 columns, will be an identity matrix. Basically leaving me with, remember that was x's, y's, and z's. So this is 1x plus 0y and 0z is 8. No x plus y plus no z is a 10. And 0 plus 0, or 0x, 0y, just z equals 6. A much easier interpretation compared to that old REF equation, right, where we had to go back and back substitute and solve. So that one's basically already solved. Let's take a look at another set of these. I'm just going to click through it fairly slowly. Feel free to pause at any point and decide what you would do next. See if I accomplish the same task. See if my numbers work out. So again, I'll walk through it fairly slowly here. First, I need my augmented matrix. Then I'm going to get my 1 in the upper left corner. So I just swapped row B. Remember, I can switch rows. So I swapped row B up into the top row there. Now, as long as I'm at it, I may as well use that 1 to get rid of this 2 for that next row. So you'll notice next thing that I have is I took A minus 2B, right? 2 minus 2 is going to give me that 0. But again, I'm writing that in row 2 where I want that 0. Same thing, if I multiply that third row by a 2 and then add that to A, I should end up with, oh, and look, I took a little different route. 1 plus negative 1. If I add rows B and C, hey, that's easy enough. If I just add those 2 rows, I also get a 0. Well, I want to turn this 8 into a 1. So again, I'm going to keep row 1, but I'm going to multiply by 1/8 here, and divide by 8. Get my 1 where I wanted it. Don't worry about the fractions, they'll work their way out. And hey, as long as I'm at it, if I multiply this row by 4 and add it onto that second row, I should get that 0 I'm looking for. So again, 4 times E plus F, I got my 0. Well, I like row 1. And I like row 2. But again, I'm going to change my rows, because now, hey, if I've got my 1s and my 0s below them, I want to get my 0s above. So again, I'm going to multiply row H, I'm going to take advantage of that 1, and I'm going to eliminate the 2 numbers above it. I'm going to get these 0s up here. Again, follow the notation. That's why we write it down. That's why it's so important to follow that notation toward your goal. Last thing to do, again, I like the last 2 rows here. What I need to do is get rid of this negative 3 though. So again, 3 times row 2, well, 0, 3, 0, and 108. I'm going to add those numbers onto that first row. We should end up with 22, which just means, once again, that x plus y plus z, right? Or x equals, I should say, not x plus y plus z, x equals 22. Y equals 36, and Z equals 114. Now, one of the major advantages is we can actually check those answers on our calculator. Our calculator is really good at Gauss-Jordan Elimination. So the first thing I'm going to do is go to my matrix menu, second x to the negative 1, and I'm going to put in a matrix. I'm going to go to Edit, and I'm going to edit this matrix. I'm going to make it a 3 by 4 matrix, and then I'm going to enter my numbers in. So through the magic of video, I went ahead and entered those numbers in. Notice that again in that last row there was a 0 for Z. Don't forget to make sure that 0 is in there. But again, I've got my 2, 28, and 14 down here. And again, if we check our numbers here, I've got all my coefficients, right? My coefficient matrix here in my first 3 columns. Well, I'm going to go back to the main screen. And one huge advantage again of your calculator are the things that it can do. If I go to my math menu, and then I go to the bottom of the list, you'll notice that pretty close to the bottom, there's an option for RREF. So if I grab that option, then I'm going to go back to Matrix, and I'm going to grab Matrix A. And very quick and simple, just hit Enter, and you'll notice there are our numbers, 22, 36, and 114. It doesn't get much faster than that. Feel free to try that with the matrix on our next screen. Even though it's a really big matrix, it'll work. And there's our answer for us. X, Y, Z, and W, we've got our numbers. Good luck and happy matrices.